I don't know about you, but I like to combine things that I love. And so I like physics and I like Star Wars. And so when I can find a way to merge those two, I do it. This is a scene from Mandalorian, which I like that show. Uh, and we could talk about Mandalorian all you want, but let's just do some physics. So this is season 2. This is the second to the last episode. So I mean, I'm not really spoiling any plot here because I just have a small clip of it. Let me just scroll through the clip and because whenever I watch a show like this, I see stuff and I'm like, whoa, look at that, and I'm looking for an opportunity to kind of analyze it. So I see these guys are jumping, and right here, look at that. Just that little clip right there. You see? They're jumping, and the camera, there's a couple of important points right here. The camera is relatively far away. It's a side view, and it's moving along with these vehicles. So I could get and they kind of look, it kind of looks, there's something weird looking about that too. And I just want to get the plot, the motion of these guys as they jump. And that's what I'm going to do. So I've already loaded the clip up here in Tracker Video. How do you get the clip? I'm not going to tell you because I'm not allowed to. So the first thing I want to do is trim this clip. This is Tracker Video. I'll put a link down below. It's a video analysis program. It's free. It's awesome. It runs on Mac, Windows, Linux. It's Java based. That's not great, but what the heck, whatever. So this is my little scrub bar down here. You can drag this little bottom arrow and it's to the beginning of the clip. I've kind of rough edited it. Now look right here. I don't want that, right? I want right there. Actually, I skipped one frame. Let's go back to 99. 98. 99. No. 99. That's 100. I can do it manually, but 99 right there. That's the clip I want. And now let's not worry about the end. Now let's switch back over here. The other thing I want to think about is how am I going to, I want to get position time data. And so I'm going to need to mark the location of a person in each frame, but I need to know the where the coordinate system is. I need to know the scale. So I can pick the scale based on the size of one of these people. What about the origin? I don't want to put the origin on the ground because everything's moving past the ground. Instead, I'm going to have a moving coordinate system. My moving coordinate system is going to be this truck. Now, the question is that going to work? Is there panning? Is there zooming? What's going on? So let's just go back to the clip and scroll through it. You can scroll through in Tracker too, but this works better here. So is there zooming? I don't think so. It looks like it's not. And does the camera shake? Yes. So I'm going to need to adjust that. Does it rotate? Maybe a little bit. So let's go back over here and let's pick a coordinate system. So this little button right here puts a coordinate system, and I need to mark a location where I want that coordinate system to be so I can move it around. I'm going to put the back corner of this vehicle right there, and that looks fairly nice. I know that things are moving around. I'm going to keep it vertical like that. And then I'll just move it around. Now, if I want to move the coordinate system, I need to go up here to coordinate system and uncheck fixed origin. I'm going to uncheck fixed angle too, just in case I want to change the angle. You can rotate the coordinate system. And just so for more complicated systems, you can do calibration point pairs. I'll make down here. I'm not going to do that here, and I'll make another video about that some other time. So the first thing I want to do is go through each frame of the video and mark the location of the origin, or move the origin so it stays in the same spot. So to do that, let's go ahead and zoom in a little bit. Let's say 200%. Okay, that's good. Now I want to put it somewhere where I can recognize it. You see this little corner right there? I'm going to put it right there. How do you like that? Okay, now I'm going to step forward a frame and see the relative motion of the truck with respect to the camera did change. So I just adjust that. Skip a frame again. It didn't skip. Skip a frame again. I'm just going to move it. I could rotate that. I'm not going to rotate it. I don't think I have to, if I don't have to rotate it, I'm not going to rotate it. And I'm not worrying about the people. I'm just worrying about the coordinate system right now. So I'm just going to do this. Let's talk about something while I'm doing this because no one wants just to see me. Uh, there's always cool things in a movie that you can analyze. And look, no one knows more than I do that these things are not real. But if I can get some measure of their motion, it could tell me a couple things. Are these real people jumping, or is this CGI? Or maybe it's really good CGI and I can't tell the difference. But I could tell if it's CGI if it doesn't have realistic motion, which doesn't mean it's a bad show. It's a great show. I don't care if the science is perfect. Obviously, it's not going to be perfect, right? That's what makes science fiction and fantasy, Star Wars is space fantasy, so great, is that it is a step out of reality. It brings us out of reality. It's amazing that I can have nice, deep conversations while clicking on each frame of the video. And the nice thing about this one too, this particular clip is short, okay? So, and I don't even know what I'm looking for yet. All I'm doing is analyzing it. We're going to find out what happens together. We're working on this together. See, now look right there. It's kind of a little hard to see, but I'm kind of lining it up with this part of the truck and that part. Is it not a truck? I don't know. And yes, the season 2 finale came out today. I have not watched it yet, so don't spoil it for me. And I'm not spoiling any plot here, so I think this is safe, right? I mean, this could be anything. You don't know who those guys are. You don't know who's driving the truck. You don't know anything. Maybe you've never even seen The Mandalorian, which you should. Okay, if you're a Star Wars fan, I really enjoy The Mandalorian because it's getting not quite that way, but it's a small side street story. Oh, see, look, something passed in front of the camera right there. I guess it's a tree. Again, is that real? Probably not. Most of this stuff was filmed in this this thing called the volume. It's a giant circular cylindrical room where the walls are all LED screens, video screens, and they can project the background onto those. I don't know if they did that here. This looks like it's on location because that's how good of a job they do. Okay, that's it. So there you go. If you go back one frame, you'll notice here 125 is the last frame. So I could drag this down to 125, but I'm going to go up here to the video panel, the clip settings, and I'm going to just move this over here, and I'm going to say the in frame is 125. Now, also up here, you could change the frame rate, how many, what's the time interval between frames. I'm just going to leave that alone, and you'll notice that clip move right there. Okay, let's go back to fit, and now, I need to do one other thing. I need to set the scale. So over here, I'm going to click this new calibration stick. And I'm going to use this guy right here. It's not going to be great, but that's fine. I'm going to go from his foot to his head. If he's a normal human, okay, we're talking 1.7 meters, somewhere around there. I don't really know how tall he is, but that's not his full stretched out length. I'm just going to say 1.5. And if it's wrong, it's wrong, but that's a good way to start. And now I can move this out of the way. And I'm going to assume that doesn't change. Okay, now let's go back to the beginning of the clip, right there. And I want to pick a guy. Let me go back to my video. Which guy do I want to look at first? Okay, so I have this first guy would be a good option. Because he lands and then does some. Let's use the second guy. Because the second guy's in there the whole time. Okay, so I'm going to go to Create, Point Mass. And there's my first guy. There's my second guy. Now what I'm going to do, let's zoom in. Let's go back to 200%. And there's my guy. Okay, I'm going to click on his center of mass, which I don't know, but I'm going to guess it's right around his belly button. So I'm going to hold down the Shift key, and I'm going to click, and it will move forward a frame, and it records the time, the X and Y values according to that axis. Now I'm going to do it again. This won't take very long. There is an auto tracker that you could, go through and find the motion and it could just do it automatically, but it doesn't. I don't need to do that. There's not that many frames. Okay, let's move this up a little bit. And you got to think, what is that guy doing, right? He is moving in the air, so now see his feet are bending and stuff. That changes the center mass, but I'm just going to kind of click in the same location. I don't think it matters too much. And we could repeat this for the other people. Oh, I got to show you another trick. Let's see, let me finish clicking this. I think that's almost it. Okay, there's that tree that passed by, so I'm almost at the end. A couple more clicks. One last click. I think this is it. Okay, that's it. Okay, so now let me show you this trick. So if I pull this window up right here, I like this a lot. Whenever you move the reference frame, you have that video, but I also get this world view. So if I go back over here, and you can export this, and it really makes a cool video. Watch this frame down here. This is kind of adjusted to stay in the same, such that the coordinate system stays constant. So it moves the video around to do that, and I really like that. Okay. But what can we find out about the motion of that sky? The first thing is, here's my position as a function of time. I'm going to analyze this. So I right-click on that and go to Analyze. And you'll notice that he appears to have a constant, why is it negative slope? That's weird. His position, oh, he's moving in the negative. He is moving, that's right. He's moving in the negative direction. That's true. Okay, so where'd my thing go? Right here. Oh, crap. View, data builder. I think that's what it was. Analyze. Let's just analyze it again. I think I'll bring it up. Okay, there. So one of the things that's weird right here is this change in velocity. It kind of seems like a change in velocity. It kind of slows down in the middle. And that could be because the vehicles change speed, right? And let's just go ahead and find the velocity of this. I'm going to go click Analyze, Curve Fit. And there I get the slope is negative 3.4 meters per second based on my scale. And this is the velocity relative to my coordinate system, which is on the truck. Okay, so that's that. And it does seem apparently different. He does speed up. Now that could be because the coordinate system sped up, right? Now he's gone 5.4. That would make sense. But if we have no air resistance, which there probably would be a little bit of air resistance, it depends on how fast this whole thing's going, then without any external forces except for the gravitational force pulling down, you would have a constant velocity in the horizontal direction. This is mostly constant, so this looks pretty good. And I'm not really sure about that little shift in velocity. I mean, it's a significant shift. But let's go back and look at the y velocity. So if I click right here, I can change this to the y position, and now I'll analyze that. And it brings up, it includes the x in there too, but I want to get rid of that just because I don't like it. And does that look like a parabola? I think it kind of does, but let's just fit let's highlight all that data. And then I'm going to do a curve fit, but I'm going to change it to a parabola. And that actually looks pretty good. I mean, all things considering, right? And so if a person jumps in the air, then they should have a constant vertical acceleration. Their position versus time should be a parabola, and this is a parabola. The t squared term, the coefficient in front of the t squared term, according to the kinematic equation, this should be negative 1/2 gt squared. So the acceleration, the a term, the a coefficient should be half a g, right? It should be 4.9. And you see here I have 1.75. So what does this mean? Well, first of all, it's not on Earth, so it doesn't have to have a gravitational field of 9.8, but it was filmed on Earth. However, I suspect that this is, I'm going to make a claim, and I could be wrong. I'm going to make a claim that this was indeed real people filmed. Okay, real people jumping. But in order to make it look a little bit cooler, they slowed it down. So we could, and I'm not going to do it, but I'll leave this as a homework for you. We could find out the new time scale, change the time scale. Okay, I will do this. Change, and I'm just going to guess. We could calculate, but I'm going to guess. We could adjust the time scale such that this is actually negative 4.9. And so what that means is that it would be real people, they filmed it, and then they slowed it down to make the acceleration it just makes it look cooler. Okay, so let's go back over here to our clip settings. I'm just going to guess. You could calculate this, but I'm going to guess. So this says a frame rate of 0.42. So let's say I want it to go faster. So each frame is, let's see, what would that be? If each frame is a shorter time, so let's say half as much, let's say 2, 1, and then click OK. Now I'm going to go back over here to reanalyze. And now you'll see that I have the acceleration's negative 6.9. So it's almost in half speed. And in fact, it could indeed be just half speed. And people like to pick half speeds, right? Because again, I guessed at two things here. I guessed at the scale. I said that guy was 1.5 meters. Maybe that was a little. Maybe if I change that to 1.4, I bet I'll get a better value. Let's see if I can find that up here. Where did I put my scale? I'll put it in here to fit. There it is. Let's say it's 1.4. And that changed everything. And then if I go back to analyze, it's still too big. Okay, so, there's really three things you can deal with when you're dealing with projectile motion. There's the vertical acceleration, there's the time scale, what's the frame rate, and then there's the distance scale. If you know two of those, you can find the third. In this case, there's two things I don't actually know. Well, there's three. I don't actually know G, right? Because it doesn't have to be Earth. I think it's probably Earth. So I would say I know G. I could pretty much get a good value for the time, for the scale, the distance scale, because these are people. They're actually actors. And then I could solve for the frame rate, and I would say pretty much it's half speed. It's really close to that. So there you go. That's a video analysis of these jumping guys from The Mandalorian. Now, if you want to do this yourself, you can look at the motion of these other people. You could try to estimate the speed of the car. You could try to estimate what kind of air drag they would have on them. If you want to look at the speed of the car, you're going to have to look at the motion of some object in the background relative to that. And then you could get the size of the vehicle and all this stuff. So there's a whole bunch of cool stuff that you can do. And I'm really just getting you started. But you guys go out and have a great time and do some physics with The Mandalorian. No spoilers, please. So I'll talk to you later.